So my next question is about the Large Hadron Collider. Is it going to create, I mean, do you have any idea of what's going to come out afterwards? Are we going to be around to see it? Because, you know, I've been hearing stories about a black hole that's going to eat all of, you know, everything.
Well, any day now, the Large Hadron Collider is going to be turned on. It is 17 miles in circumference. It is the largest machine of science ever built. You could put Manhattan inside the Large Hadron Collider. That's how big it is. 10 billion euros for this fantastic machine. In principle, it could create mini black holes, but it's not going to eat up the Earth for several reasons. First of all, the energy of these black holes wouldn't even light up a light bulb. These are subatomic, smaller than a proton. They're not going to even light up a flashlight. Second of all, the Earth gets hit with them all the time. The Earth gets bombarded with particles much more energetic than anything a puny Large Hadron Collider can do. And these particles decay. They decay almost instantly. Now, what we really want to get out of the Large Hadron Collider is something that is so fantastic, it could rewrite all of science. We want to create something called sparticles. Super particles that represent the next set of vibrations of the superstring.
It's got a real chipper name. I like that.
This is fantastic. We are now on the verge of being able to detect signals from the 11th dimension, signals from hyperspace.
Did you say 11th dimension?
11 dimensions.
What about the other, you know, 8, 7 in between?
Well, no, we live in a three-dimensional world.
Oh, okay, so we're not
I'm
going
not
to
sure
see
what
those.
dimension you live in.
I'm on the internet, you know, these things happen.
Right, but the point is that we live in a three-dimensional world, but in our three-dimensional world, there's not enough room to unite all the forces of nature. Gravity, light, the nuclear force. In 3 dimensions is too small. We've tried to put these forces together in 3 dimensions and it failed. But in 11 dimensions, these forces just melt together into one beautiful, gorgeous theory that would allow us to, quote, read the mind of God. This is Einstein's dream, a theory of everything, an equation 1 inch long that would summarize all physical knowledge of the universe. That's string theory, and we hope to test part of it by creating sparticles with the Large Hadron Collider. And that'll allow us to pick up signals from the 11th dimension. These are excitations from the 11th dimension, from hyperspace, measured in Geneva, Switzerland. Now, you may say to yourself, why Geneva? Why not Dallas, Texas? Our machine was to be based in Dallas, Texas. But on the last day of hearings, a congressman asked the physicist, are we going to find God with your machine? If so, I will vote for it. The poor physicist didn't know what to say. So he said, blah, 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 blah. He said, the Higgs boson. At that point, all the jaws hit the floor. $11 billion for another god-darn subatomic particle. They took the vote the next day, and it was canceled. And since then, we physicists have replayed that scene over and over in our minds. What should we have said if someone says, will we find God with your machine?
You have an answer?
I have an answer.
Okay.
I would have said something like this. I would have said, God, by whatever signs or symbols you ascribe to the deity, this machine will take us as close as humanly possible to his or her greatest creation, Genesis. This is a Genesis machine. This machine will recreate some of the nuclear fire that gave birth to the heavens and the earth. Instead, we said Higgs boson, and the machine was canceled. And that's why it's debuting in Geneva now, a much smaller machine debuting in Switzerland.